I will be talking to you about 2016 AP Chemistry FRQ question number 2. For part A, this is an acid and base reaction. As we know, precipitate reaction indicates the reactions that will have solid formed at the end of the reaction, and reduction reaction refers to the reactions which element changes their oxidation numbers throughout the reaction. However, in this case, none of this happened, so the reaction is neither precipitate reaction or redox reaction. So the answer for this question is acid and base reaction. So on the screen I wrote the appropriate answer for this question. Question B is asking about limiting reactant. So we use stoichiometry to solve this question, and we calculate the moles of each reactant. For 2.24 grams of NaHCO3, it's 84 grams per mole, so we get the number of 0.0267 mole of NaHCO3. So there are 60 milliliter of HC2H3O2. Its molarity was given in the question, so every 1000 milliliter there's 0.875 mole. So the number turned out to be there are 0.052 mole of HC2H3O2. So in this question, NaHCO3 is the limiting reactant because if these two solutions react together in 1:1 ratio, NaHCO3 runs out first. Therefore, NaHCO3 is the limiting reactant in this question. Part C asks why the bubbling slows down as the reaction continues. Because as the reaction goes on, the reactants are consumed, so the concentration of the reactant decreases. So the collision of the reacting particles decreases as the concentration decreases. So the reaction rate decreases. So DI asks which drives the chemical reaction between NaHCO3 and HC2H3O2, and the answers are entropy only, enthalpy only, or both entropy and enthalpy. And the answer for this one is entropy only, and I will explain in DII. So in DII, the question asks to explain part DI in terms of delta G. So we know the formula of delta G equals delta H minus T delta S. So to make the reaction to be thermodynamically favorable, delta G should be negative, as we all know. So since the reaction is getting cooler, it's a endothermic reaction, so delta H is positive. So there are no gas in the reactant, but a gas is produced in a reaction. So delta S is going to be positive because T is always positive in this question, so negative T delta S is more negative, so delta G will be more negative. So part E asks to draw a Lewis electron dot diagram for the HCO3 minus ion. So we count the total number of electrons of the elements in HCO3 negative, which is 23 electrons, but since it's a -1 ion, so there are 24 electrons. So we just draw the Lewis structure. So O connects to C, and then C connects to O and O, and then H connects to the other side of O, and then there are 24 dots, so one oxygen should be double bound. So that's our diagram. However, in the question, it mentions there are two of these diagrams, so we draw the resonance structure of our diagram in this question. And a resonance structure is just how elements are bound differently in the compound. So part F asks to write a balanced net ionic equation for the reaction between NH3 and the chemical species in the example that is responsible for the pH remaining at 4.7. So we write this like H2H3O2 minus, which comes from NaC2H3O2, and plus H plus, which comes from HNO3, and it forms HC2H3O2, which makes the pH remaining at 4.7. So now I will point out how the College Board assigned the points into this question. So for part A, if you answer it's an acid and base reaction, it's 1 point, and then the reason it's the other point. And for part B, if you write the two equations, it's 1 point. Explanation, it's 1 point. C, the correct explanation, it's 1 point. D, if you circle the right answer, it's 1 point. The right explanation, it's 1 point. And then part E, one diagram is 1 point, and then if you draw both diagram, which is correct, it's the other point. And for part F, which is not shown in here, if you write the correct net ionic equation, it's the last 1 point. So that's total 10 points for this question. Thank you for watching my video. I hope it was helpful to you.